In this video we'll be having a look at how to sketch a type 1 rational function, and you can see the example there, and so we'll go straight into it. What we can do is we can say that y equals 4 over 2x plus 1, and immediately we can find the y-intercept, which is when x equals 0. So x equals 0, you end up with 4 over 0 plus 1, which equals 4. So the y-intercept must be 0, 4. So we've got that as a result. Let's go with the x-intercept, which is when y equals 0. So when y equals 0, we have 4 over 2x plus 1. Now, the 2x plus 1 on the denominator here, that's dividing. So if I multiply both sides by 2x plus 1, or depending on how you've been taught, you could take the 2x plus 1 to the other side. Now, the yellow part is dividing, so the yellow part will multiply. This will imply then that 0 times 2x plus 1 equals 4. So in other words, 0 equals 4. So in other words, what's happened here is we've got a false statement. So this will imply what? Well, we're trying to find the x-intercept, and there isn't one. So there's no x-intercept. Okay, so there's no x-intercept. Right, now what we're going to do next is look at if we can find the asymptotes. And we know the easiest one is to find the vertical asymptote. And we discussed before, this is when the denominator is 0. When we put the denominator to 0, we obviously saying we're dividing by 0, which we can't do. So when does that happen? Well, it's quite simple. Take negative 1 off both sides. 2x equals negative 1, divide by 2, and divide by 2. So this implies that x equals minus half is our vertical asymptote. Okay. Horizontal asymptote is where we're looking left and right and trying to see what's the behavior of the graph when x gets really, really big or x gets really, really small. So we're looking here at the horizontal asymptote. Now there is a nice little, not a trick, but it's something that we can do which works and we've looked at in class, which is, this is our function and we can do whatever we want to it as long as we do the same to both sides. Or with fraction terms, whatever we do to the top, let's do to the bottom. Now I've written it out again, only because I'm changing colour here. The highest, the highest degree, x here, is power 1. And it's the only x there. So I'm going to divide everything by x. And if I divide all the terms in the fraction by x, that is a true statement. There's nothing wrong with that. So y is now 4 over x, 2 plus 1 over x, because the x's will cancel out here and here. Now, why have I done that? What we're going to do is when x gets really, 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 really big, so let's send that off to infinity. Well, y, what will happen to y? Well, 4 over infinity, 4 divided by something really, really big, will eventually become 0. 1 over x, so 1 over something really, 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 really big, will eventually become 0. So we end up with 0 over 2, which is 0. So what we're saying is when x gets really, really big, y is going to be 0. That's our horizontal asymptote. So let's have a look at see what we've got now. These are what we call critical values. We've got our axes x-intercepts and we've got our asymptotes. So let's have a see what we've got. We know the general shape is going to be a curve, and we can say this. Let's have a look down here. Let's start the sketch. If we need to put more in later, we will. But let's see if we can start the sketch in the usual way. We have, let's have a look. When x is 0, y is 4 is our y-intercept. Which we're going to put there. We have no x-intercept. We have no x-intercept. We do have a vertical asymptote when x is negative a half, which would imply down here somewhere. I'll just change colour on that. So x is negative a half, and we also have an asymptote when y equals 0. So that's y equals 0 there. Okay. Now what we can do, we're not sure which way the graph is going or what it's going to look like. What we can do is bring in the idea of just looking along the horizontal axis. Where are the critical values for x? Well, when x is negative a half, we know that y is infinite. When x is 0, we know that y is 4. And that's it. So we've divided an x-axis into 3 sections. So let's have a look. When x is bigger than 0, let's write out our function again, which I've done, 4 over 2x plus 1. Okay, and we're going to look at when x is bigger than 0, which is this section along here. So when x is bigger than 0, let's have a look at the positive or negativeness of the y. Well, on the top is 4, which is always positive, and the bottom will be positive times 2 plus 1, which will give us a positive. So the y values are always positive in this section here. So anywhere bigger than 4, we have y values are positive. What about between 0 and negative 1? Negative a half. This section here, what would happen? Well, the top is positive. It's never going to change in this case. And what we have now is a fraction, a negative fraction. Okay, and the fraction is smaller than a half. So 2 lots of that will be smaller than 1. You get the idea? So if we choose, say, for example, minus a quarter, and 2 times minus a quarter is minus a half, plus 1 is positive. So y is positive in this section too. So we've got between minus half and 0, we've got another positive value. Let's go to the last section, which is x is less than minus a half. Well, think of a nice easy number if you're not sure about this. Let's say minus 1. Well, we know that y has to be positive on the top in this case because it's 4. And let's go with minus 1. So when x is minus 1, the denominator gives us negative 2 plus 1, which is negative. Okay, so let's put all that together on our little sketch. We have a definite intercept at 4. We know that this side, where x is bigger than 0, the y value must be above the axis. This is an asymptote. So we're going to have something that does that. Now watch what happens between 0 and minus a half. It is still positive. The y values are still positive. So that would be going to that asymptote there. We know that when x is less than minus a half, the y values are negative. So the y values will never cross the x-axis. They're always below. And we're going to be looking at that shape. It's got the same shape that we've seen before. And that's the graph.